Last time we covered the basics of decisions with the switch statement, but there is much more that the switch statement can do. Swift's switch statement is much more flexible than those of its predecessors. So let's take a closer look into how Swift 2.0 implements switch. Now, before talking about the next feature of the switch statement, we actually need to discuss another language feature of Swift, which is the range. A range is actually a type in Swift, but they are used so often that the syntax of the language gives you an operator to create them. And actually there are two operators. So a range is going to have an upper bound and a lower bound. And the difference in the two operators is that the range produced by one operator includes the lower bound and the other one excludes the upper bound. So the closed range operator is going to be the one that includes the upper bound of the range. So I'm going to create a constant, call it closed range, and then 0, 3 dots, and 10. Now using the Alt Option key and clicking on closed range, we can see that it is of type range and that the elements in the range are restricted to be ints. Now this syntax here represents what's called a generic, and we're going to discuss it more later on, but for right now just know that it prevents types that are not int from being in this particular range. Now to prove that a closed range includes the upper bound, what I'm going to do is I'm going to call the max element method on the closed range value. And we'll see that the maximum element here is 10, which is the upper bound that we specified. The other kind of range, the half-open range, excludes the upper bound, and the operator for it will create a new constant called half-open range, is going to be 2 dots and then the less than sign. So what I'll do here is I'll again confirm that the half-open range has a maximum element which should be only 9, because it's excluding the upper bound of 10. Now something interesting to note is that the playground always represents closed ranges as their half-open equivalent. Now that we understand ranges, we can look at how to use them to match cases in a switch statement. Suppose we have a shipping application and want to determine the price to ship packages based on their weight. We can define the weight classes as ranges, which will be matched using cases in a switch statement. If we switch on the weight of the package to be shipped, the case that has a range, which includes the weight, will be matched. And it looks something like this. Here I'm defining 3 half-open ranges. The first one will match any weight up to 5 pounds. The second one from 5 pounds up to 20 pounds. The third one from 20 pounds up to 50 pounds. Now for 50 pounds and up, we can just use the default case. I've defined the weight of the package to be 10 pounds, and so therefore that will fall in this case here, and that will make the price per pound to be this value. If I were to change the weight to 25 pounds, it will fall into the next weight class. Notice that I'm defining price per pound as a constant with a type annotation of double. Since the price per pound will not need to change after it has been set, and the lack of implicit fall-through will only allow one case to be matched, I can ensure that the value will not be changed after it is initialized. So that's not all that can be done with a switch statement. There's even more, but first we need to discuss some special data types in Swift called collections. In the next video, we'll look at what they are and how they can be used.